Okay, now we are on to the second part of the video. We are done with the demo. We have gotten the output, but the real question is, how did this file of 3 GB got executed in almost 50 seconds, 45 seconds? And as I've already explained, different processes are running right now, so it's taking a bit more time. But but still, how did it still access it in such a quick time? So basically what happens, and as I explained to you, that the file the concept of this assignment was to use multi-threading concept to basically break the file into different chunks, or basically break the content of the file into different chunks, as I should say. So this is the first question. This is without affinity and everything. You've got the libraries included. The chrono library is only for the clock. So this clock, basically the execution time, as you can see in all of the cases, this just basically displays that. So now in our code, I have basically made a mutex. I've explained to you what a mutex means. Mutex is basically used for synchronization. It is used for the thread synchronization so that it can lock that the area and prevent from a race condition. So I've made it a map. This map is basically for the global word frequency. Like, what is the frequency of the global word count? This is the this is basically this over here is basically the global word count, the global vowel count. Now, why I have named these global? Because these can be accessed by many threads at one at a time. As you will see in this analyze chunk function, you will see that we have created a local word count. What is the what is the reason that we created a local word count? The local word count was created so as to, for example, if I had 4 threads in the program, and all 4 threads were accessing this one variable, we had this one variable global word count. So there would have been a few problems in basically synchronizing the answers in different cases. So if I had run it in 8 threads, it would have given me a different answer. If I would have run the code for 4 threads, it would have given me a different answer. So that's why we created a global count. So whenever my thread comes in, it will basically use this local word count to change basically the total number of words in the final answer. So as you can see, you can see over here that this is the concept we're using the mutexes. So over here we're basically updating the global word count with the local word count, local vowel count that we had. So we updated over here. Why did we use mutex lock over here? Because now this is the area where most of the threads can come, and they can and they can have the race conditions. So to prevent race conditions, we used this mutex over here. This is basically divide file into chunks. This is that part of the code where basically dividing the file into different chunks. You have to remember one thing in the file. One problem that this assignment had was that, for example, in my dataset case, you had a word I am Hasnan. So what would have happened? There was a problem I faced, that one thread would have come, it would have used this word I. Okay, very good, this is counted, it's gone. It would have used the next thread would have come. I'm using 4 threads, for example. It would have accessed this word, but at the same time, what would have happened is that there would have been another word coming in, another thread coming in, actually, I should say, and it would have accessed this word M. So it would have said that I is another word, A is another word, and M is another word, which is obviously a wrong output. Again, in case of Hasnan, it would have might have divided Hasnan into 3, 4, 5 parts. Who knows? That was a huge problem. So this is the role that I had to use, basically a start and a last index, basically for dividing the file, so that we should know that when I'm dividing a file into chunks, so this is I am C++. So we should know that this is the start, the end. So this is one chunk. Then this whole is one chunk. You can't divide M into 2 chunks. No, that would have been wrong. M is one chunk, C++ is one chunk, or you can say I am C++ is one chunk, or I am is one chunk and C++ is a second chunk. That's how this program divides the files content into different chunks. And as you know, this is basically a 3.1 GB file, so it divided that into different chunks. Over here, I'm basically taking the argument at the terminal. As you can see over here, I mentioned 8 threads, so it basically shows you over here that these are the 8 threads we take in terminal of. Then we basically divide the file into chunks. Then we basically call the create, we will call the create function of the threads. And then we start, after we've called the create, before joining the threads, because once threads finish, they wait for each other and then they join. Before joining them, we basically start measuring the execution time. And then at the end of this, we basically sort all the top 10 frequent words, and then we see out the execution time after ending it over here. After the joining time, we end it over here. Okay, now on to question number B. Over here, only one thing is different. All implementation is same. We have added affinity. So in the affinity, I can show you that in the thread arguments, as you can see in this one, in this case, there was no structure of the thread argument. So we didn't have to create one. It wasn't needed at all. But over here, we created a structure for thread arguments. Over here, we assigned it a CPU core ID so that it's thread affinity. I've explained the affinity process, that basically it's better for the CPU utilization or the cache locality and different things. So that's why we use the CPU core ID. It may take a bit longer time. That's never sure, but the utilization of the CPU is much better in affinities case. Okay, as given in the table in the report as well. This is the question 2. In this question, there's only a few differences as compared to the previous question. Now in this case, we have to basically find out all the unique words. So again, same map made, the global total word, the unique words, we do the chunk processor. And the chunk processor, again, as you can see, we basically have a local word frequency. Again, I've already explained to you over here why we had to make a global frequency, because if we didn't make a global, if we didn't make a local frequency, that would have caused the threads to access the global variant, and it would have updated it time after time. So even if the total words were 10, it might have given it the output as 16 or 20 or even more than this. So that's to prevent that, we did this. Again, the mutex lock is used over here. You can see that the global total words is being incremented with the local word count, and you use lock because the global variable is being accessed, the global point is being accessed. That's why we use the mutex. This is the file splitter. Again, you have to use the same concept of the start and the last indexes. We are basically again using the 3.1 GB file. Again, we are using the terminal input, and then over here we've got the auto end time, start time, using the chrono library. For the affinity thing, I forgot to tell you, we have to use this library. This is called the shed.h library. And we come to the last question. Again, using affinity, we have again made a thread argument, which basically is the processor ID. Okay, you might have wondered, what is this text chunk, or over here, what is this text segment? So it's very self-explanatory, as I've already given a lot of comments over here. This is basically a pointer to a chunk of a text. So for example, you had a text which mentioned that C++ is more powerful than ever, for example. So it would have basically given you a pointer to one of the chunks of this. You might have divided into this chunk. So this is one chunk and this is one chunk. So that's how the thread chunks work. And this is a short explanation of how my code works, why it uses the local variables, how does the global variable update, why the use of mutex is important, and why is the affinity important in this case as well. Always remember, execution time is maybe in some cases not that important. It's how your threads utilize the CPU. In case of 8 threads, it will approximately utilize about 80 to 90% of your laptop's requirements or your PC requirements. That said, it depends upon the cores that your PC has. Mine has 8, so it utilized approximately 89% of the CPU when using 8 threads. But for some cases that I ran my code on different PCs which had 4 cores, over there even 4 threads utilized about 75 to 80% of the total CPU utilization. So obviously this will depend upon the hardware that you have, but also the way this has been coded. So 8 threads will give you maximum utilization. I hope this explains the concept of multi-threading and as to why this was really important in this assignment and to specifically accessing this 3.1 GB file. Thank you.